Hello. I'm privileged to present to you the work about using EM technology as an ecological solution for infertile riverbank at the Sorek River in Israel, presented by myself, Asher Maimon, and also with the help of my colleagues Ori Moran and Amir Elron from Israel. EM technology, if some of you is not familiar with, is a living microbial blend, contains mainly lactic acid bacteria, photosynthetic bacteria, and yeasts. Coming from nature with no chemical additives, no GMO. Its method of action is competitive exclusion. As we know, it was developed by Dr. Higa, who's present here, and promoted by EMRO at about 150 countries around the world these days. Sorek River is firstly mentioned in the Old Testament, in the Bible, at the book of Judges, at about 720 BC. This is the scene when Samson meets Delilah. And it collects water from Jerusalem mountain areas all the way to the Mediterranean Sea. This is Tel Aviv, Yafo, and this is the area of our pilot, the Red Star. And this project was done in cooperation with the Israeli Nature and Park Authority and also the Authority for Drainage and the Sorek River by itself. The story of this river is sad but funny, or sad in a way, because it's the story of, look at this beautiful river. It's a story about sewage flowing for 40 years, causing mosquitoes to come, causing bites for citizens. Citizens complain, authorities bring pest control. They are trying to access the water, but there is so much wild plants on the banks, so they spray the banks with herbicides, and then they spray the water. Now 40 years after, we come to try to restore it, trying to plant something, and nothing is growing because the soil is infertile. And what we're trying to do is to create a strong enough plants that will hold the soil before the first tide of the winter is coming. Because first tide is coming is going to wash everything that is not stable enough. And we have a limited time of the summer in Israel. And summers in Israel are quite hot. This is how it looks, the region of the pilot that we did. This is the river. This is the bank that we did, the work was done on. It's marked here with this rectangular. And this is what's happening when the tides are coming and the banks are not held good enough. It's really, trees are collapsing in, and the river is becoming wider and wider by each season. So what we did is this is the river. We took 19 test plots. Each one of them is 1 meter wide and 20 meter long. And we divided them into 4 categories. One of them is with chemical treatments, and then 13 treatments with EM, different treatments, which I will describe in a minute. Control treatments, and then active carbon. We had also 6 vertical stripes, which I'll show in a minute as well, and planted 24 different wild species in those plots. This table is detailing all the different treatments in each one of the plots, but in a way the parameters we tested were the categories I mentioned, active carbon, chemical treatment, and control. Another parameter is low versus high EM pre-plant dose. We also did the nylon cover of the plot to support semi-anaerobic fermentation before planting. Continuous foliar feed with EM, application of cow dung bokashi, it's cow dung fermented with EM. Also application of EMX ceramic powder, which also is an EM style of application, and application of sugarcane molasses to support the living bacteria. These are the cross sections I mentioned before. This is the river flowing. We have 6 stripes according to the distance from the water. We call it A1, A2, B1, B2, B3, and then C. And these are the plants that were planted in this pilot. This is how it looks in real life. The bank, the pilot area, active carbon application. This is applying EMX ceramic on one of the plot here. This is tilling in the molasses, planting. This is covering with nylon some of the plots, watering after planting, and this is just a general look. And the results that we found. We had plenty of data collected. What we did is we sampled the data that can give us the total biomass of the above ground parts of the plants. And this was done for each one of the stripes, A1, A2, B1, B2, B3, and C, and it was sampled twice along the growing season. And now this is just to give you the quantities of data, but we'll go into details in the next slides. And this is on the x-axis, you can see these are the plots according to the categories I mentioned before: chemical treatment, EM, control, and active carbon. This data that we did before, we called it the growth index. We named it the growth index. This is the total biomass of the above ground parts of the plants. Now we're going for some analysis. If we compare the EM versus no EM, the category, according to 4 categories, chemical treatment, we can see the growth index of the 6 stripes according to the representation here and here. This is the average of all the EM treatments, control and active carbon. So we can see that EM has a better growth index compared to the other categories. Now we compare the application of small versus large EM pre-plant dose. This is a comparison done here only in 2 plots. Plot 5 is a small application. Plot 12 is the large application. We see some of the lines are going up. Growth index is going up. Some is down. This probably is a mistake somewhere on the way. So we cannot. We can say that we cannot deduct so much here. Nylon cover effect, again, comparing plot 11 covered with nylon, plot 12 not covered with nylon. We can see the nice decline of the line, the growth index, so we can deduct that the nylon cover has supported the better growth of the growth index. Post-planting foliar feed with EM, comparing again plot 8 with it, plot 7 without it. We have one line going up for stripe B3. Stripe C is declining a little bit, but the other stripes are declining in a stronger way. In a way, we can say that foliar feed, continuous foliar feed along the season has supported the growth index as well. Cow dung bokashi, comparing plot 4 with it, plot 2 without it. Again, some are going up, some going down. Stripe C is probably a mistake somewhere on the way. We couldn't deduct anything from here. And the last one, one before last for this analysis, stripe 7 for EMX ceramic powder, stripe 7 with it, stripe 6 without it. Again, a nice decline of the growth index. So we could deduct that EMX ceramics is supporting and benefiting for the growth index here. Sugarcane molasses, plot 9 versus plot 7. Again, going up and down. It's a mixture. No clear deduction, no clear conclusion here. Some further analysis that we did. We went only to stripe B2, which is placed at the slope center. It's not diluted by the flow of the water. It has uniform soil layers according to soil checks that were done. And we tested here, what we were presenting here, only one plant, Luchea diascaridis, which is a typical riverbank plant and was found to represent the general situation in our pilot. This is the data that was for this situation, but I will try and read those numbers or the comparisons that are down here. If we're going to compare only the EM, which gave us almost 400, active carbon 380, EM is a bit higher, but still have the peaks of 4 and 9, which are the highest. Control 86, much lower than 400. Chemical 140, much lower again. Pre-plant dose, high versus small, 360 compared to 660. In this situation, the large dose, pre-plant dose of EM was much better. Nylon cover, when it's covered, gave us a bit less than 300. When it's not covered, 660. In this situation, covering with nylon was less beneficial for the growth index. Foliar feed, 564 compared to 500. A bit similar, but still better for the foliar feed. Cow dung bokashi, about 800 compared to 100, much better with the cow dung bokashi. EMX ceramic, 500 compared to 200, much better with the EMX ceramic. Molasses, 840 compared to 500. This specific plant, it was much better using the molasses as a feed for the bacteria before planting. This is a further analysis for this stripe, for another plant, Polycharia diesenterica, but this time we took the total growth area, which contains also the area of the roots inside. It's limited on the plots because it's a lot of work to take plants out and do right measurements. But here still we can see plot 0, chemical, EM treatments, control, and active carbon. This is how it looks at the end of the growing season, the end of the summer. You can see this is on the right here, chemical treatment, EM part, untreated control, and active carbon. You can see the nice curve of the growth. This is the first tide coming in, pilot, the green area here. You can see that the plants are holding the soil and it's not washed away as we expected. It was very nice to see that when it happened. Summary, we're going through 2 schemes of growth index and for the all plants combined and the specific plant, EM versus no EM, benefiting both, large versus small dose, benefiting only in this specific plant. Nylon cover, we have contradicting results. Foliar feed, good for both of them. Cow dung bokashi, better only for the Pluchea diascaridis. EMX ceramic, better for both. Molasses, only for the Pluchea diascaridis. This is the last slide. Another interesting result that we got is germination of species from local seed bank. It was too long to present in this presentation. What was really clear for us that we saw that there were a lot of seeds that were not planted in this project that germinated mainly in the EM treatment areas. And our final conclusion is that EM technology was found to be effective and very useful as a solution for infertile banks of the Sorek River, and it is incorporated in the plans for future restoration of the river. And as of last week, we got an approval of budget for the next project, which is going to go for 2 kilometers along this area using EM in that project. So thank you very much.